go to let's go to here. So I believe what he said there was basically a squared minus b squared equals c squared. That would be the difference. The difference equals unity, and unity being the c squared.
But turned inside out. And as you can see, it still has a circle type of reality, but it's only in a expanded type of. It's very difficult to explain these kind of things. I've been working on it for years, and I still haven't come up with the final thing so you can really make it click in your head. But you can see that one goes outwards, and another one is confined. So these variations are what are called aperiodic. In other words, they do not come round and round like the circle, but they go through a basic motion, and then they're gone. They come and they go. These are what are called transient electric waves, where the alternating current waves of the circle are continuous electric waves because the rotation is constant and the unit vector is constant. So there's alternating current waves are a continuous wave, where these represent impulses that are discontinuous waves. Okay, let's go to the next slide. This represented by this graph represents the velocity of light, which must always remain constant. So that means that this
I'll just pause it there and go over the charts. Let's see. So he was saying that the addition represents continuous and AC waves, and then the subtraction, the difference, represents discontinuous transient waves. And there is a section where he goes over, there's 4 different types of waves. I don't know if I can remember all of them off the top of my head. There's an impulse wave, which I believe is like that. There is an AC wave, which is like that. There is it was the oscillating wave, which is like it gets smaller and smaller. And then there's one more. Blanking on it. And there's like variations of how they relate to each other. And then I think we'll end with this section where he goes over how light is the constant.
hyperbolic curve, where this represents frequency and this represents wavelength, the product will always remain constant. If there's continuous waves. Okay, let's go to the next slide. This represented by this graph represents the velocity of light, which must always remain constant. So that means that this hyperbolic curve, where this represents frequency and this represents wavelength, the product of the two must always equal a constant, which is the velocity of light. So like the circle, the hyperbola has a character to it that has to always equal a constant quantity, and that's what makes its shape. This also could be the Lorentz transform for the relativistic mass increase. And time dilation follows the exact same type of curve, a hyperbolic curve, where you approach something but you can never reach it. So in other words, if the frequency goes down and down and down and down and down, then by following that point along this curve, the wavelength has to get longer and longer and longer and longer until eventually when the frequency is down, the direct curve is zero, the wavelengths are of indefinite or infinite length. So we have this inverse proportion between frequency. The higher the frequency, the shorter the waves. The lower the frequency, the longer the waves. But they must always equal the velocity of light, and that forces them into this archetype of curvature or rates of change. So here's a basic example of the hyperbola in action. So let's go to the next. Okay, now we're going to, this is the...
Okay, we're going to stop there. Oh no, I was covering it. Oh, I apologize. I'm not going to redo that, but basically let me just show you the chart. that he was showing right here. I apologize for that. This is the chart. So he was saying the further you go down in wavelength, or excuse me, frequency, it eventually becomes DC, and that's so fascinating. You probably saw me drawing it. I was going to talk about it after. That means, as I understand it, DC is a wavelength of 0, and that's a really interesting aspect of this talk. So what he was talking about as well, it's like you can approach something, but you never get to it. This is an asymptote. And so what we're going to finish on is these two diagrams. So this is this is a symbolic way of representing, and this is my theory. It's an ongoing process a theory I'm looking into right now. A way to represent space and counter space. So you got 1 in the middle, and that represents principle. It represents, let me draw here. Ether, whoop, whoop. The ether at rest. And on one side you have infinity over 1, which I like to think of as like the positive infinity. This is space. This is magnetism at its greatest magnitude, its greatest expression. And then on the opposite side, we have 1 over infinity, which I like to think of as a type of negative infinity. And this represents counter space and the dielectric at its greatest value. So this is going to be, I would think, to add an additional aspect, this would be the greatest voltage when it's at the highest level of dielectric amplitude. And then on the opposite side, this would be the greatest current, possibly. These are just guess at this point. And what I find interesting about 1 over infinity is it's essentially 0. So 0 is a limit. It's not an actual number. We got infinity on the right as a limit. That's approached but never reached. And then we've got on the left 0 as a limit, which is approached but never reached. So the way I'm currently conceptualizing this is that it is related to this circular radian chart. And what he was talking about was that as this radius right here moves around the cycle, the 2 different lengths here are changing dynamically, and they're changing in such a way that they maintain proportionality of the Pythagorean addition, where one, such as this length, represents A, and another, excuse me, another length, such as B, like this one, represents B. And the third length, the radius, is represented by C. So it's hopefully coming full circle that you can see what's going on. And that's, again, why I find it so interesting that we get this chart like relating back to something in the real world, not just a triangle. It's like, why do I care about measuring a triangle? Like, maybe if I'm building something in carpentry, but for me, electricity is so much more fascinating to relate this to. So to visualize this, let's draw one more example of the purple. So that we had the red pretty long, the vertical one. if we did it where the purple was right in the middle, the red would be along the same path, and we can put orange for this horizontal aspect, this element, we can call it. It'd be 0 effectively. There's 0 length if it's right. I'm drawing it just beside so you can see the colors, but the point is it would be right along this axis, the radius, this little rotation aspect. So this length would be undefined, it'd be 0. Whereas the magnetic, that vertical one right here, would be infinite. And then we can do another one where if it's along this line, we'd have the exact opposite, where the dielectric that this represents is infinite, and the magnetic, that would be the vertical, is essentially undefined. It's 0. So fascinating. So it's almost, it's interesting the way I just said it. It's like saying when one is infinity, the other one is 0. And when the other one's infinity, the other one's 0. It's almost like they're swapping places. That's an interesting way to visualize it. So we could have like the magnetic being 0, and let's do the dielectric as blue. Even though we've already drawn it with blue, the dielectric as infinity. And that would be represented by, if we're doing the magnetic as the vertical, with it being 0, it'd be this. That's what this would represent right here. This would represent that. And then if we want to do the opposite where it's right here, let's draw that. If the motor is at right here, the magnetic would be infinity and the dielectric would be 0. So that is an interesting way to do it. Before I was thinking it might be like going to the left. Here, I'll just visually do it, like going to the left here and then coming back, going past to the middle again. Whoa. And then going to the right, and then going to the left, and then going to the right. I was thinking of it like that, where it oscillate back and forth between the two, kind of like an inhale and an exhale. But this way is much more intriguing. It's this, I can't really visualize it very easily other than just the way I drew it out there, where they flip. It's like this star, this blue star that represents the dielectric is going to move closer, and it gets less and less value, or I guess more, as it's coming from that 0 limit value. But I'm wondering in this case what the 1 would represent as it passes that. Maybe that would be actually the speed of light, the rate of perturbation as the threshold. This could be C possibly. That's an interesting way to visualize it. But no, I think 0 represents it, so I don't think that would. Well, still got more work to do on this, but I like this visualization right here so far, but I don't think it fully maps out correctly. So anyways, it's something I'm playing with. And yeah, hope you enjoyed that. Stay tuned for another upcoming video.